Yes, you guess it right. The next chapter we are going to start is motion. Actually, motion is very interesting in the field of physics, or you can say in your daily life as well. Every work you do is result of certain action, and that action may be in the form of motion. So let's look in the overview what we are going to study. That is motion, some of the related term, speed, speed with direction, velocity, acceleration, and some of the derivation. So the very first question is, what is motion? Let's assume I am moving from A to B. So this movement is known as motion. Very simple. Suppose I am starting from A and doing some of the activities, that is moving from A to B, from rest to motion in order to reach this destination known as motion. This ball moving, bouncing, and then going back are all motion, example of motion. So now we know that movement of anything is termed as motion. The next thing is, what is distance? Right, distance, it's very simple term. I said that I am moving from A to B. That is from initial point, from where I have started, to certain destination, that is final point. Right, so the distance, the length which I have covered, while doing this motion is known as distance. So basically, if I describe distance, it is like the actual length which I have covered during that particular motion. If I say that I am going hospital from my house, while going from hospital to house, or house to hospital, whatever, I am covering 5 kilometer. This 5 kilometer is my distance. I am going to park from my home, or vice versa. So I am covering 500 meter. This 500 meter is our distance. Now we can see there is some difference between this two magnitude. We can see there is difference of unit. In one case there is meter, while in another there is kilometer. So which one to prefer? It basically depends on you. You can either use meter or kilometer. But the standard unit for measuring distance is meter. So SI unit, that is better known as standard unit of measuring distance, is meter. Now how to measure distance? Suppose I want to measure distance. So there are two important things which I need to take care. One is I need to know the numerical value. See, if I'm saying I want to go to hospital, I should know in numbers how many kilometers I need to cover. So numerical value. And the another is unit. Whether to use kilometer, meter, centimeter, or millimeter, whatever you want to. Without both of them, your sentence or your statement will be senseless. So it's very important to know the accurate number as well as to use the perfect unit for that particular number. So that is distance. One thing to take care is, when we talk about distance, we don't talk about direction. I don't care where the hospital is. I just care how much length I need to cover to go to that hospital. So suppose if we started talking about the distance, or the direction, whether north, east, west or south. So when we talk about direction with distance, that term is known as displacement. here comes the next thing, that is displacement. As I said, direction, yes, so when we add direction to distance, it is known as displacement. So suppose I am saying I am moving from A to B, that the distance is 5 kilometer, but in north. So I'm adding this additional information, that is direction. So in this case, this is not distance, it is displacement. Now also, assume I am going from, you can say from A to B to C to D, right? I'm moving. So the actual distance covered will be A to B, then B to C, and C to D. But that's not the case in displacement. Why? Because displacement is the shortest distance covered. So we call that displacement is the shortest distance covered. So this is my final destination, and this is the actual this is the actual starting point. So my displacement will be directly from A to D. So my displacement in this case will be A to D, whereas distance will be plus BC plus CD. Let's make all this point little bit clear. We are going to compare distance and displacement in order to learn more about them. When I talk about distance, I talk about numerical value and unit. When I talk about displacement, I talk about numerical value, unit, and direction. Distance is scalar. Scalar means any quantity which don't have direction is known as scalar. Displacement is vector. Anything vector means it has direction. For 9 standard, this is enough. Now, distance is actual path covered, while displacement is shortest path covered. So I think this is clear now. What are the difference between distance and displacement? So now we know what motion is. Movement of anything. This is known as motion. If I'm moving from A to B, that is motion. Uniform motion. Suppose I cover equal distance. Let's suppose I'm moving from A to B and I have divided certain distance, like the distance I am covering is x, and with respect to that distance my time is t. Neither time nor the distance is changing. The ratio of them, you can say. So in this particular case, the motion is uniform motion. Equal interval of time. In particular time, we are covering equal distance. So that is uniform motion. If we cover unequal distance in equal interval of time, let's say that my time is t in each of the cases again, but the distance I am covering is not same, is changing. So in this case, we are under non-uniform motion. This is quite simple term, non-uniform and uniform motion.
Right, now we need to know what speed is. We have heard this term many a time in our daily life. Increase the speed, decrease the speed, or whatever. So what is the speed? What is the meaning of speed? We know what distance is, right? We know what time is. We know what uniform motion is. So suppose if I am moving, the time I am taking is 1 hour. The intervals I have divided is 1 hour. And I am covering 30 kilometers in 1 hour. And the next instant it is 20 kilometers. So the relative term, that is 30 kilometers per hour, is my speed. That is, I am moving with the speed of 30 kilometers per hour. Every hour I have the capability to cover the distance of 30 kilometers. That is known as speed. So speed is a relative term of distance and time. So from here it comes a formula, that is speed equals to distance by time. S means distance and V is speed. Now from here we can calculate the SI unit of speed. Alright, we have talked about SI unit in our previous time. So velocity, this is speed, right? So speed equals to distance by time. So the SI unit of distance is meter, and for the time it is second. So speed is meter per second. Meter per second. That is our speed, the SI unit of speed.
We know there are two terms known as distance and displacement, right? Distance, we already learned what distance and displacement is. I hope it is clear. So speed was distance upon time. What will happen if I replace this distance with displacement? Because at the end they are both a way to measure the length, right? One is the actual path covered and the other is the shortest path covered. So what if I replace this displacement distance with the displacement? So I'll write here displacement by time. So indirectly what we are doing is we are just adding direction in this distance, right? So when we calculate displacement by time, that thing is known as velocity. Okay, so speed with direction is known as velocity. It's quite simple, like speed equals to distance by time. In the same way, velocity is displacement by time. Now, let's talk about the quantity of speed and velocity. Speed has no time, no direction, that means speed is scalar quantity, whereas velocity, that is v, you can remember it by v and v. Velocity got some direction, that's the reason we say velocity is a vector quantity. Now, how to take the SI unit of speed and velocity? So the speed is distance by time, or you can write v equals to v, that is speed, s by t. So our distance, the SI unit of distance is meter, whereas for time it is second. So the SI unit of speed will be meter per second, or you can write meter per second, right? So basically This was all about velocity. Now how to find average velocity? Average, for instance, I say that a body is moving in a north direction. First its velocity was 30 meter per second, then it increases to 40 meter per second, then finally the final velocity was 20 meter per second. So in this case I need to find the average velocity. So what I will do is I'll take the initial velocity. Initial velocity is denoted by u plus final velocity divided by 2. So in this case the initial velocity was 36 meter per second and the final was 20 meter per second. We didn't care about the 40. Similarly, when we take out the average velocity, the only thing which we care is initial velocity and the final velocity. So which was 20 divided by 2. So it was 56 by 2. Now we just saw the final and initial velocity, right? There was some final velocity, there was some initial velocity. Let me change the color. Right. So what is acceleration? We have heard this term in our daily life. See, this rate of change of velocity from final to initial, that let's say final was 20 meter per second and the final in for this distance was 30 meter per second, right? So this change, how much time it took to come from 20 meter to 30 meter, so this rate of change of velocity is known as acceleration. So acceleration is rate of change. So you can say final minus initial. That means what was the final velocity and what was the difference of final and initial velocity divided by time. That is how much time it took to cover that particular distance or to reach that final velocity. So this is acceleration. We have learned about uniform speed and uniform velocity so far. In the same way, there is something known as uniform acceleration. We know what acceleration is. Acceleration is rate of change of velocity per unit time. That is, in simple language, rate of change of velocity. That is from initial velocity to final velocity. How much time the body is taking to change its velocity. Alright. In the same way, if the rate of change of velocity is same for certain interval of time, then it's known as uniform acceleration. Right? So for instance, let's assume that my acceleration at this point was 3 meter per second square. Here was 3 meter per second square and again it was 3 meter per second square. So the rate of change of velocity here is same. That means the motion which I am possessing is uniform motion. Also, let's try to find out the SI unit of acceleration. SI unit is standard unit, right? So we know acceleration is difference of velocity with respect to time. So the difference of any unit will be the same one. If I divide meter from meter, so it will be meter only. So in case of acceleration, we need to find the SI unit of velocity, which is meter per second. Now find that of time, which is second. When we combine them both, it will be meter per second square. So this meter per second square is the SI unit of acceleration. And also, acceleration is a vector quantity. Now, some of the example of uniform acceleration can be free fall. Free fall is if a body is placed in certain height and if it's going downward. So there will be a natural acceleration and the motion which it will tends will have a uniform acceleration, or you can say if a ball is rolling in such kind of curve, or you can say a motion of a ball rolling in an inclined plane. Now we are about to end this chapter. If a body is moving in a straight line with a uniform acceleration, we just learned what is uniform acceleration. If the rate of change of velocity is same for certain interval of time, then it is uniform acceleration. So if the body is possessing uniform acceleration, in that case there are three equations which we can use while solving certain numericals. So the first one is v equals to u plus at, s equals to ut plus half at square, and v square equals to u square plus 2as. Right, these are certain equations. So we are going to prove this. That is v final velocity equals to initial velocity plus at. We know that acceleration is v minus u by t. So in this case we'll multiply a with the t and then bring this u this side, and finally the leftover is final velocity. So we just know how it came, but we are going to solve this with the help of graph. Okay, so we have made the graph. In this graph, A to B, this A and B is the motion of the body, right? It's reaching certain velocity with a constant increase. You can say the increase is acceleration. Now this OC is the time, and this OY, that is the y-axis, is its velocity. Right, now we are going to make an angle, that is the constant increase in the velocity. So this type of graph is known as velocity time graph. This OC is the time, and this OE or OY is the velocity, and this was its initial velocity, and this BC is considered as the final velocity. So now what we are going to do is we are going to take an angle, that is theta, because that's the increase in rate of increase in this AB, right? So now we are going to put some values, that is acceleration of this body the acceleration of this body will be the slope of velocity time graph, slope of graph, right? So we need to find the slope, we need to find the value of this angle theta. So what we can do is acceleration of the body equals to tan theta, and we know theta is perpendicular by base. See, if this is a triangle and this is right 90 degree, so this AD, this is D, AD will be its base and BD will be perpendicular. This is a formula you will study in 10th standard, that tan theta is perpendicular by base. For now just remember it. So perpendicular by base. Now what is perpendicular? In this case BD is my perpendicular and the base is AD, right? Now the next thing I can do is I can replace this value, or you can say I can put the value. If suppose I am having 8 as my value, so I can write 8 equals to 10 minus 2, because that's how equations are formed. So here what I can do is here I can write this BD as BC minus DC. So BD will be equal to BC minus DC. Alright, this is my equation number 1 and I'll say this as equation number 2. I have replaced BD by BC minus DC. So this is my BC. I hope it is visible. See, what I am doing is I have a line that is BC. It is having center, not center, a point in it that is known as D. So if I will remove DC from this BC, what I will get is BD. So unfortunately we are just doing the 10 minus 8 kind of stuff. Now I need to change the value of AD. So AD, this AD will be equals to OC. And the OC is T. So this is my equation number 3. Now what I am going to do is I am going to put equation number 2 and 3 in 1. So acceleration is equals to BD. BD is BC minus DC. And AD, which is equals to time. So BC, as I already mentioned, BC is final velocity and DC is initial velocity. DC will be equals to AO. And then the time. So finally, acceleration equals to, what we got is acceleration equals to V minus U by T, or I can say AT plus U equals to V. So this is how we derive our first equation. Now moving on to the next one. The graph will be same. We'll be having same graph. Now in this case, what will we do? We'll find the distance. So this type of graph is known as position time graph. We'll try to relate the position and the time of the graph. So here I am going to find the distance. Now I need to find the distance of the shaded area. So what I will do is I'll find the distance of triangle and then of the rectangle. So it's very simple. What I can do is area of rectangle and that is AO and DC plus area of triangle, that is ABD. So in position time relation, what we are actually going to do is we'll find the area of triangle ABD and area of rectangle AODC. So how do we find the area of rectangle? That is length into breadth, and for the triangle one we do half into base into height. Now we are going to find the length and breadth of the rectangle. So the length, it will be simple, OC into AO plus half. For the base of this particular triangle will be AD and its height will be BD. Now again OC into AO will be, this AO is initial velocity and OC is time. So it will be U into T plus half. Now AD will be equals to OC. So I'll write OC instead of AD. Why? Because they are equal. Because length, or you can say the breadth of the parameter, will be same. So AD will be equals to OC. Now again I am going to do 10 minus 8 equals to 10 minus 2 stuff. Here what we'll do, we will write BD as BC minus DC, right? So in this place, in the place of BD, I'm going to write BC minus DC. Now whatever the value I'm having, I'm going to put that. This is UT plus half, OC will be time, and BC minus DC, it's going to be, you can say this BC is final velocity and DC is equals to AO, you can say initial velocity. So the equation which I am getting is UT plus half V minus U into T. This is not what we wanted, right? This is something different. So what we are going to do is, we already derived our first equation, that was A equals to V minus U by T. So wherever in this place I'm getting V minus U, I'm going to put AT, right? So in this place of V minus U, I'm going to put AT, which will result into UT plus half AT into T. So I am writing the final result with a red pen. So the final conclusion will be S equals to UT plus half AT square. This is what we wanted. So here comes the end of this second derivation, that is position time relation. What we did is, we simply find the area of this shaded part. Now again we are going to do the same thing, but in this case we are considering the whole A shape, and the shape which I have drawn is of trapezium. So in this third derivation, we are going to find V square minus U square equals to 2AS. This is the equation we need to derive, and the graph is for position velocity. The relation of position and velocity. Now, so again we are going to find the distance traveled, S. So this is the simplest derivation of all the three. You need to find the area of trapezium, and for your sake I'm going to simplify it. The area of trapezium, you can see the shape. Trapezium is O, A, B and C, and this is its height, right? The AD is the height. So the area of trapezium is sum of parallel side. You know what parallel side is, right? Divided by 2 into distance between this parallel side. So the parallel side in this case will be OA plus CB divided by 2, and this OA and BC will be the parallel side. If you don't know what parallel side is, parallel lines means the lines which are never going to intersect, no matter how much we extend them. So if suppose I'm taking a rectangle, this is not. So the side of rectangles are parallel sides. Similarly, this is a trapezium and two sides of trapezium are parallel, and the distance between them is the height. So AD is the distance between those parallel sides. So it is AD, right? So now I can write AD as OC because they are same. OA, this is OA, which is initial velocity. and this is CB, which is final velocity, no doubt, divided by 2. And this AD is written as OC. I can write AD as OC, which is equals to time. So I'm writing time over here. Now we have derived earlier that V equals to U plus AT. So I can write V minus U upon A equals to T. Right? This is we have already derived. So wherever in this equation I am getting T, I'll write this value. If I say A equals to 5 and my equation is A square plus B plus C, so wherever I am getting this A, I'll write is at 5. So that will become 5 square plus B plus C. So in the same manner, wherever in this equation I am finding T, I'll write V minus U by A. So it will become U plus V by T into V minus U by A. Now we already know there is one formula known as A plus B, A minus B, which is equals to A square minus B square. Right? If this is A plus B and there is A minus B, so we can write it as A square minus B square. So this will become V square minus U square by 2A, which is equals to S. Or in short, you can write it as, you can just bring that 2A in that side, which will become 2AS equals to V square minus U square. And this was our needed equation. Alright, so this was the third and the last equation. I hope this is clear to you. I want to add one thing, that is circular motion. This is kind of easy stuff. See, if any body is moving in a circle, or you can say if it's changing its direction every second in every point, then the motion is known as circular motion. It can be oval also. The motion can be in the oval also, spiral also. So this kind of motion is known as circular motion. The special thing about circular motion is body needs acceleration every time. Why? Because it is changing its shape, direction every time. Like every other motion, circular motion can also be defined, classified as as uniform circular motion and non-uniform circular motion. So there are many examples of non-uniform. For uniform, I want to give you one example, that is if this is the earth and moon is rotating, that's the example of uniform circular motion. Or you can say this is a sun and every planet or satellite or whatever is rotating in its orbit. So that's the example of uniform circular motion. From daily life, you can say watch you're wearing or the fan above you. They are all the example of circular motion. Now how to find the speed of circular motion? We know speed equals to distance covered by time. So in this case, suppose this is my circle, the distance which will be covered by an body in motion will be 2 pi r by t. So this is my speed. Alright, so here our chapter ends. I guess this was an easy chapter. In this chapter, we studied about speed, velocity. If you are in hurry, you can skip this part. Speed, velocity, distance, displacement, acceleration, three equations of motion. If you want me to make video on any topic, just comment down. Thank you for watching.